My name is Emily Newman. I am the program manager of the organic crop consulting team with Rodale Institute. I'll be moderating today's session as we discuss planting green techniques and its potential applications in organic no-till and rotational tillage systems. We did host two other webinars, one on February 3rd, and then another on the 10th, all about rotational no-till, innovative weed management control, planting cover crops, but today is going to be focusing on planting green. This webinar will feature a few presentations followed by an open question and answer session with the speakers, as well as a few additional experts in the topic area. In addition to the Rodale Institute, this webinar was supported by the Pennsylvania Department of Agriculture, Northeast SARE, and Penn State Extension. So thank you to all the sponsors and to the organizers who made these three webinars happen. All the webinars will be recorded and are currently being recorded for future use and reference. It will be emailed after the fact, as well as include a survey that participants are encouraged to take. It's my pleasure to welcome all of our speakers today. We are joined by Dr. Heidi Reed, who's going to discuss proven planting green techniques and equipment used by farmers in Pennsylvania. We also have Leah Varek, an organic crop consultant with Rodale Institute. She's going to discuss her experience with organic no-till from her research with Dr. Aaron Silva at University of Wisconsin. And Lamont Garber is here today as well from Stroud Water Research, and he's going to provide a bit of an update on the watershed impact trial in Pennsylvania as well. So before we get started, I just want to give a brief introduction to Zoom. If you aren't familiar with it, if you hover over the screen with your mouse, a few items will appear at the bottom left. You'll see a microphone and a video camera, which you can turn on and off yourselves. Please, as I said in the beginning, keep your microphone muted. You're more than welcome to turn your video on to see other participants. There's also going to be a chat box at the bottom, so please feel free to use that chat box to ask questions to the panelists, and we will get to those at the end, as well as an opportunity to give reactions. So feel free to use an emoji to express your interest in a particular subject. So again, please mute your mics if you're not speaking, but please turn on your video camera if you can. And then at the top right corner, you can actually change your screen to either gallery view or speaker view. Right now, it's likely in speaker view to see the presentation and me as a speaker. Same will go when the other presenters are speaking. So without further ado, I'm going to stop sharing my screen and allow Dr. Heidi Reed.
Thanks, Emily. All right, just a second. All right, can you see my screen and hear me all right? Super, okay. My name is Heidi Reed. I am an agronomy educator for Penn State Extension. I'm based in York County, Pennsylvania, which is in the south central, southeastern part of the state. And you can see my contact information down there. If we don't happen to answer one of your questions today, please feel free to follow up with me. I'll be talking about my graduate research that was done between 2015 and 2017, and it was on planting green. And I need to be upfront with everybody. It was in a conventional no-till system, so this wasn't in an organic system. However, I think we learned a lot of lessons that will apply to organic systems because the way the agroecosystem works will be similar, except, you know, without the addition of several inputs. So I'm going to talk a little bit about what we learned and how this could potentially apply to organic no-till or organic reduced tillage systems. So for those of you who are unfamiliar with planting green is when a cash crop is planted into a living cover crop or into a cover crop that was recently sprayed in a conventional system, and it can look something like this. So this particular setup is a small 4-row John Deere conservation corn planter that has the Dawn ZRX residue managers installed, and those are mini rollers and residue managers that go on each row unit. These are becoming more frequently used. Sorry, someone's saying my name. Okay, these are being more frequently used in conventional systems. This is not enough to provide a complete kill in an organic system. An additional pass with a large roller crimper would be needed. The drum style would be needed for a complete kill, but this does help push down, break the stems of mature enough cover crops, and it does provide that knockdown power and allows the planter to go through. So we did an experiment over 3 years at 5 different locations in Pennsylvania. 3 of those locations were farmer cooperator sites, and 2 of the locations were Penn State research farms. And I'm just going to give you really simplified take homes from what we learned over those 15 site years of research we did with planting green with soybeans. And we had 12 site year locations where we planted green with corn. So when I talk about planting green, it's always in comparison to an early killed cover crop. So it's not in comparison to fallow or bare ground. It's in comparison to a cover crop that was chemically terminated with a herbicide approximately 2 weeks prior to planting. So we have that early kill, that's brown, what you see here in the center of the screen, compared to planting green, which looks like, you know, just standing rye, standing cover crop on the day of planting. What we found, the first big take home, was that planting green allows for a huge increase in biomass. And we know from lots of prior research that cover crop ecosystem services are very tightly tied to how much biomass is out there. The more biomass we have, and the longer the cover crop stays in the field, the more ecosystem services we can reap from those covers. And, you know, the more bang for your buck you can get as a farmer out of your cover crops. The second big take home that we found was that compared to the early killed cover crop, planting green significantly dried the soil at cash crop planting, but then it conserved soil moisture later in the growing season. So this figure here is an example. All of our sites followed a similar trend. This was just one site year I picked because it was really nice and tidy. Here we have soil moisture from 0 to 3 inch depth on the vertical axis, and this is just time from date of planting, May 19th to early August, and we sampled approximately weekly during the growing season. And you can see the solid line here is the planted green treatment, and the dotted line is the early kill treatment. So if we follow the planted green, whoops, we can see it's the soil significantly drier at planting. And then by approximately 2 or 3 weeks later, we have significantly wetter soils. So this trend occurred to different levels across all our site years. And the third big takeaway we found was that planting green significantly cools soil compared to when we kill the cover crop early. Here, again, this figure shows time on the horizontal axis, and we have our temperature on the vertical axis. Our dotted line is the early killed cover crop, and the solid line is where we planted green. So This difference could be, you know, 0.5 degree to 1 degree Fahrenheit, and maxed out at 7 or 8 degrees Fahrenheit, which is a huge difference in temperature when they're measured at the same time. So all of these three effects on the agro ecosystem, they interact with one another, and they can provide benefits for us, but they can also cause challenges. And I think it's important to acknowledge those challenges up front so we can change our management and have the best, best success possible. So we had challenges with establishment in some circumstances when we planted green compared to a typical early burn down of cover crops. And, you know, this could be compared to rolling a typical organic cover crop termination of rolling a couple of weeks before and letting it, you know, turn brown and die. So we had some situations where we did not have a corn planter to use. We used a grain drill for establishing soybeans. And then in these circumstances, as you can see here, we also happened to have a high nitrogen environment. We had a windstorm. It was like the perfect storm, and we had lodging of the cover crop. And then we tried to go through it with a grain drill, and establishment was really poor. The good news is soybeans can adapt to reduced populations, but had this been a cornfield, this would have been a tragic reduction in plant population and would have required reseeding. So establishment is something to that needs to be done well to have success with planting green, especially with corn. Pests, we did find that we had mixed results with our pest population. So when we started the project, we went in hypothesizing that planting green would reduce our slug injury to our crops, because we had farmer anecdotes saying, yeah, I plant green, it provides alternate food for the slugs so that they're not eating my corn as it's emerging, or they're not eating my soybean. It's an alternate food source, and we also thought it would provide habitat for our beneficials, which could maybe help suppress pests like slugs as well. Well, we found mixed results. There were some circumstances where planting green significantly reduced our slug feeding in our cash crops, and some circumstances where there was no difference, and some where it significantly increased feeding. So at this point in time, we're not confident that planting green itself is actually going to cause reduced slug feeding, although there's still lots of anecdotal evidence out there, which is also valid. We also saw some interesting pests. We had greater bill bug damage, greater stink bug damage in planting green. But we saw in 1 year, we had a breakout of black cutworm, and we had significantly less black cutworm damage when we planted green compared to where we early killed the cover crop. So the effect on pests is mixed, depends on the species of cover crop, depends on the species of pest, and what your long-term management is if you have those suites of predators and good insects out there to help provide that pest management for you. And something that I think will be the biggest challenge, was a challenge in a conventional system that can be somewhat easily remedied, but will, I think, be the biggest issue in an organic system trying to do this, is nitrogen management in corn. So we did look at planting green into cereal rye and planting green into crimson clover, as well as a mix between the two, and compared all of those to the early killed version. And we found, regardless of cover crop species, we had some nitrogen tie-up by the cover crop when we planted green compared to the early kill. So you can see, the left half of this picture is obviously nitrogen stressed. We were able to fix that with our side dress application. We put more nitrogen on. That corn came out of that deficient state, and it did okay. In 1 year, there was a significant yield reduction where we planted green, and in the other, there was no difference. However, anytime you let your cover crop get very mature, the carbon to nitrogen ratio increases. And anytime our C to N ratio is above 25, we know that it's going to be immobilizing nitrogen when it goes into the soil. So we need to expect that when we kill the cover crop at such a late stage. And I know that in organic systems, if you're using a rye cover crop and you're rolling a couple of weeks before, that rye cover crop's very mature. It's at anthesis to get a good kill. However, it has those couple of weeks as it's dying and decomposing for that nitrogen to be released. Same thing with hairy vetch. If it's at full bloom, it is a legume, yes, but it is still most likely higher in C to N ratio than 25 to 1. So there can potentially be N tie-up even with our legume cover crops. So I do see this as a big challenge for organic growers who don't have the synthetic options that conventional folks do. I do think more research needs to be done on whether this can be remedied with the manure or the products that you do have available to you. This is a list that we compiled of our current best management practices for planting green. And we've pretty conclusively found that starting with soybeans is the best thing to do. It's much easier to do successfully than corn, especially because of that nitrogen issue in the organic system, as well as any issues with establishment you might have in soybeans, reduced populations because your residue was not managed well or got out of hand. Soybeans can deal with that lower population. Corn cannot. Corn has one ear most times per plant. So every time you lose a plant, you're losing an ear and you're losing yield. Where soybeans can put on branches and pods and compensate. We recommend reducing the cover crop seeding rate in conventional systems because part of my project looked at different cereal rye seeding rates, 30 pounds per acre, 60 pounds per acre, 120 pounds per acre. There was no difference in biomass when we planted green between those three seeding rates. However, I understand in an organic system when you're using that cover crop biomass as your main method of weed management, probably keeping the seeding rate high is something you'll still have to do, but there is a potential to save some money on seed by reducing the seeding rate if it's right for your situation. In our experience, killing early in a dry spring and when the forecast is predicted to continue to be dry is the best move. So that living cover crop is continuing to transpire and grow and take up soil moisture from the soil profile. And at a certain point, it's robbing moisture from the cash crop should you become moisture limited. And this is also important for folks who are joining from maybe a place that's not subhumid or is in a lower rainfall regime, west of the Mississippi River. You need to be more careful, or other arid areas it's more risky than here where we have ample rainfall. We recommend rolling any cover crop that's knee high or taller, though planting green can be done without rolling. We recommend the use of aggressive row cleaners. Now, again, in an organic system where this opens up the opportunity for weeds to populate, that might not be the best practice in an organic system. Again, use of a planter instead of a drill, better singulation, better seed placement, better depth control. It just works better. And then understanding the importance of the C/N ratio of your cover crops, so important for managing nitrogen and understanding the decomposition of your cover crop and the services it's going to provide you over time. Of course, scouting and using IPM. IPM is, integral part of organic production, so that's not news to you all. And then having a planting green mentor, someone who's done it well. Might be tough to find someone who's done it organically and successfully, but there's more and more conventional folks who are using this practice and doing it well and really enjoy it and see the benefits of it. So I think I might end on a couple equipment notes. So really quickly. So planting green can be done with a lot of different types of equipment. Doing it organically, of course, you need the roller crimper to provide the cover crop kill. So that does add that as a necessity for doing this organically. But in terms of things like row cleaners and closing wheels and firming wheels and all these different attachments to the planter, it's not one size fits all. It varies farm to farm. What's your preference? And yeah, we have not found one particular setup to be great in every situation. So with that, I'll end it there. And yeah, thank you.
Thanks so much, Heidi. That was awesome. Next, we have gotten some questions and we are going to hold them to the end. I'll allow for all of the panelists to get the chance to answer some of those questions. So next, I'm going to invite Leah to share her screen and talk about her experience with this research. Hi, Leah, we can't hear you. Sorry. Let's actually, Lamont, if you're available right now to chat, we'll let Leah get resituated with her microphone. We did test before, but sometimes that stuff happens with technology. So.
Sure. Can you hear me?
Yep.
Okay. Hi, everyone. I'm Lamont Garber, and I work for the Stroud Water Research Center, which is in Avondale, Pennsylvania, which is about halfway between Lancaster and Philadelphia in southeastern Pennsylvania. And I wanted to give a few remarks today on some research that we're doing with the Rodale Institute related to soil health and different cropping systems. And wanted to also say a few things about the Pennsylvania No-Till Alliance and their work with planting green, just because Jim Hershey was not able to be with us today. So I'm going to start my slides here in just a moment. Okay. So Stroud Water Research Center, as I mentioned, we're in southeastern Pennsylvania, and we just celebrated our 50th anniversary a couple of years ago. We were established in 1967 as a place to study how streams and rivers and freshwater systems generally function, so that we can both inform others about how to get their own streams in a healthy condition, as well as assist landowners, particularly farmers, in water-friendly, stream-friendly farming systems. And the Stroud Water Research Center is basically comprised of 3 different departments. As you see there on the left, research is our bread and butter at Stroud. We have a number of different research programs underway that study everything from chemistry to microbiology to fluvial geomorphology, everything that it takes to understand how freshwater systems work. We have an education program where we inform students and public officials and others about how to better understand the streams flowing through their properties. And thirdly, we have a watershed restoration group, which is who I work for. And there's very good collaboration between these 3 departments, but in recent years, I would say we have really strengthened the collaboration between particularly my group that works with farmers and our research team. And it's in this area of soil health where we've really seen a lot of potential to improve the waterways of Pennsylvania and throughout this country and really in other parts of the world. And we see improved soils on farms as potentially one of the most powerful ways to improve the performance of watersheds and the streams and rivers flowing through their watersheds. So I want to tell you a little bit about some of the soil health research we're looking at. First, our very first soil health research project at Stroud was a very simple one, and it was to look at the impact of cover crops on water quality. Cover crops are a widely recognized best practice for good soil and crop management. There's really no dispute anymore about how important cover crops are in a productive farming system that is also going to be building that soil resource through time. What we wanted to look at was in an otherwise good, well-managed farming system, how does the use of cover crops affect water quality as opposed to no cover crops? And we have some fields nearby Stroud that are farmed by a very good farmer. And we were able to basically set up trials where we're collecting runoff from fields, both with cover crops and with non-cover crops, to see what the water quality effects are of these practices. So not necessarily planting green, I would say, but instead just the very simple questions around what effects do cover crops have on water quality and the amount and the quality of the stormwater runoff flowing off these fields in an otherwise pretty well-managed system. So we use weirs like this to collect runoff at the bottom of a field, and then we can run those samples through a battery of tests. It does take storms, however, to generate data. We need lots of rainfall falling on fields, particularly well-managed fields like this, in order to generate enough runoff to collect samples. But not surprisingly, we found pretty stark differences between no-till fields that had cover crops versus no-till fields that did not have cover crops. These are conventional fields, I will say. And sediment was just one parameter we've been looking at, and the water was certainly cleaner, and there was less of it running off these fields that were flowing over fields that had cover crops as compared to those that did not. Perhaps not surprising to a lot of us, but we actually found not a lot of water quality research in cover crop trials that were being conducted around the country. So we wanted to add this set of data to that growing body of knowledge. But like I said, this was our first set of trials in a pretty simple setup, research design. So then several years ago, the Rodale Institute and the Stroud Center, with support from the William Penn Foundation, started a 6-year research trial, of which we are just in the middle of right now, where we're looking at the role of organic, conventional, and conventional conservation practices and their effect on soil health and water quality. And as I said, we're sort of midway through this research. So I don't have any final data to share with you today, but it's a program, it's a research project that both of our organizations are really, really excited about. And we thank the William Penn Foundation for their support. Basically, we are looking at the impact of various farm management decisions related to such things as the use of cover crops, fertilizer regimes, different tillage practices, and use of pesticides. What effect those different farm management systems are having, one, on soil health that are underlaying those various farming systems, those various treatments, and then what direct effect are those different systems having on water quality, as well as what happens to water quality through time as the soil health changes with these different practices. We have 2 sites that we are doing this research on. On the left-hand side, you see the long-term farming systems trial at the Rodale Institute in Emmaus, and it's much flatter ground. We have very long-term data that Rodale has been accumulating over the years here, and so it's a great baseline to be able to be looking at. Our second set of fields are at the Stroud Preserve in Chester County, about an hour south of Emmaus. And you can see the layout of the various treatments where we go from organic tillage, organic with tillage, organic no-till, conventional with tillage, and conservation conventional across this very hilly landscape. It's important to look at the effect of different farming systems, both in flatter ground like we have at Rodale, but also highly sloped ground that we have at Stroud Preserve, because that really reflects the reality that we're farming in Pennsylvania, where we have lots of different topography, from very flat to very, very hilly, that farmers are looking at. As a stream health organization, Stroud Water Research Center is really interested in what we find out from this research program. And there's a couple of really key questions that we are interested in finding answers to. Obviously, there is this trade-off between tillage that can work very well with weed control and the use of pesticides to control weeds. So what effect is tillage versus no-till having on runoff in terms of the delivery of sediment and nutrients to the streams that are below these farm fields? Secondly, though, because pesticides are more typically used in conventional no-till systems, what is the impact of insecticides, such as that family of insecticides called neonicotinoids? What's the effect, not just on the soil insects that we're very concerned about, but also the aquatic insects that are in our streams? As you may know, aquatic insects, or what we call macroinvertebrates, are our leading indicator for the health of a stream. So if there's runoff from a farm field that is carrying dissolved insecticides in either through groundwater base flow into the stream or direct surface flow runoff, it's likely to be having an effect on that aquatic insect community. And it's something that we're very concerned about. And finally, how does improved soil health under organic or conventional systems, how does improved soil health affect the infiltration rates on these fields? It's a huge question for our waterways, because not only does a field that is infiltrating rainfall more effectively cause less runoff during the storm, if we're getting more infiltration into those farm fields, some of which is flowing below the root zone and into the aquifer below that farm, what that means is the stream at the bottom of the hill is going to have more cool, clean water flowing into that stream as base flow during those dangerous summer months when high stream temperatures can actually really be toxic for aquatic insects and fish. So more infiltration on healthier soils on our farm fields probably means we're going to be getting more cooler water in those stressful summer months flowing into our streams and keeping our aquatic organisms healthier. I just want to say a few things about the Pennsylvania No-Till Alliance. It's an organization that we collaborate with very closely, and that is Jim Hershey that you see on the left-hand side of your screen. The Pennsylvania No-Till Alliance is a farmer-to-farmer network that's been around now for at least 15 or 20 years. And they are basically a bunch of farmers that want to share information with other Pennsylvania farmers on how to farm better so that as farmers, they can improve the health of the soils while maintaining a very high level of production. And Jim Hershey is the president of the PA No-Till Alliance, and he is a big advocate for planting green. He talks about planting green wherever he goes and talks to farmers. And in fact, you can see the field day he hosted over there on the right in 2019, where he's demonstrating a planting green system where people are gathered around in real time, seeing his equipment. He and his staff at his farm have actually built their own interseeders to plant cover crops into growing corn. So Jim is using both interseeding techniques as well as planting green techniques to get the most out of his cover crops that he possibly can. And I think that I want to show you another farm, the Schrack farm, and Jim Harbaugh, who is also in the Pennsylvania No-Till Alliance. Here is a picture of them planting green in a very, very tall cover crop. The reason why I think that the farmers in the Pennsylvania No-Till Alliance are so interested in both planting green and in interseeding, which is basically establishing planting cover crop seeds into a standing commodity crop, right? That's interseeding, a whole additional topic. The reason these farmers are really interested in these techniques is that they've been working with no-till and cover crops and good crop rotations for many years. They've seen the improvements in their own soils over the last few decades. They've seen organic matter increase. They've seen improved nutrient cycling in their soils. But many of them are looking at some plateaus that they're seeing, for example, in organic matter, and trying to figure out how can they keep pushing their soils to even higher levels of performance and conditions. And that's why they're looking at these systems like Heidi was talking about, planting green, because they want to keep pushing and achieving better and better soil health. And so I would say, like the board of directors of the PA No-Till Alliance, all of them are either using planting green techniques across all their fields, or they're experimenting with this practice. And I would just encourage any of the farmers out there, whether or not you live in Pennsylvania, to just consider attending one of the the Pennsylvania No-Till Alliance field days in the summertime. You'll be able to see a lot of these techniques demonstrated before your very eyes. So with that, I'll end and thank the Rodale Institute and all of you for the chance to bring these thoughts to you.
Thank you so much, Lamont. I love hearing about the PA No-Till Alliance. We're sad that Jim Hershey wasn't able to join us today, but I'm very appreciative that you brought to light his innovative methods, even though he couldn't be here. I'm hoping that we can maybe talk a little bit more about interseeding in the panel discussion. So having the opportunity to have Leah or Heidi or anybody talk about that method, because it is a very important method in the no-till system. So Leah, can you confirm that your microphone is working?
Do you hear me this time?
We do. Awesome.
Nice.
Feel free to share your screen and I'll let you do your presentation next.
Thank you, Emily. It is too bad I was not able to follow Heidi's talk because it is very complementary to what she has been presenting. So today I will be talking about data that, as Emily mentioned, has been collected at the University of Wisconsin-Madison when I was working with Dr. Erin Silva, who studies organic systems there. So I will be talking about planting green and soybeans into cereal rye, like Heidi did, but here I will be talking about organic systems only. As far as locations, so all the research I will be presenting was conducted at the Arlington Agricultural Research Station, which is located in south central Wisconsin, where the arrow points, I don't know if this is an international audience or not. So if, as compared to Pennsylvania, I guess our climate is a little more continental, which means our winter are a little harder, colder. And so it's a little harder to have cover crop over winter, and everything in the spring is shifted a couple, maybe a week or so later than what you observe in Pennsylvania. And so what I will be talking about here is how does the system where, I don't know who is familiar with the planting soybeans into rolled down rye system, but it is a system in which we plant rye in the fall, and then we come back in the following spring and we plant soybeans into the rolled rye. And a big question that has been asked about the system lately is, how do I manage to plant my soybeans earlier? So let me walk you through the program here first. So we plant the rye in mid to late September. In Wisconsin, we don't want to go any later than the end of September, very early October. In Pennsylvania, you may be able to push it a little bit. And what is important for us is that we plant at a high seeding rate and we plant early. So we plant at a high seeding rate of 3 million seeds per acre. So that's anywhere between 140 to 200 pounds per acre, depending on your seed count. So that is one of the most important thing in the system, planting early and heavy. And after that, we come back in June if you're going to plant into the roll down rye, because that is when the rye is at anthesis, which is the flowering stage, and you see the anthers coming out of the head. And that's the stage at which you would want to roll, crimp the rye to terminate it and plant the soybeans into it. And so the way farmers have been wondering how they could push it earlier is to plant the soybeans green into the standing rye and come back later at that same time when the rye is at anthesis to roll down the rye and the soybeans growing into it. So what we've been looking at here is planting the soybeans when the rye is at boot stage. So that occurs between May 10th and May 15th in Wisconsin. And boot stage is when you can see the heads of the rye are just about, or here they're actually popping out of the stem a little bit, but that would be around that time when the heads are barely out, or you can see between the last and the previous to last node that the stem is swelling a little bit because the head is going to pop out. So this is boot stage, and that's what we've been targeting to plant our soybeans. So they're big enough to crimp on top of them and on top of the rye at the end of May, early June, when the rye reaches anthesis. And here I put soybean stage question mark because I don't have the answer as to what is the best soybean stage to crimp on top of the soybeans. One information here is that what we have been doing is that we've been consistently rolling on top of the soybeans when they were at the unifoliate unfolded. So it's not the first trifoliate, it's just those first two leaves. So the first leaves of the soybeans only have 2 leaflets, as opposed to the following leaves that have 3 leaflets each. So this is also called VC stage. And I would highly discourage anyone to roll soybeans before that stage, as they may just be smashed by the roller crimper. The part that I don't have the answer to is how far can we crimp them? How big can we crimp them? There has been a little bit of research done on that, and I think what the main recommendation is to not go beyond V3, which is the 3rd trifoliate leaf, fully unfolded. So it seems like anywhere between the unifoliate unfolded and the 3rd trifoliate unfolded is kind of where you want to be to crimp those soybeans, and that's going to be important in timing your planting of the soybeans into the standing right. It's really going to depend on your location. And here I'm going to dive into the data very deep. And I just put together this data recently, asking myself, why do you observe lower yields when we plant early at boot stage as opposed to planting later at anthesis? And so you will have to follow my train here. So here is what I call control, is the soybeans planted into bare ground. So we plant them when it's in bare ground, but at the same time as the rise at boot stage. So this is around May 15, planted when the rise at anthesis into bare ground. So around the end of May, early June. And the stands are pretty consistent. Doesn't matter really when we plant the soybeans in bare ground. We get the same stand. The population here that we plant is 225,000 seeds per acre, whether it is in the control or in the no-till system. The yields are also fairly consistent. It doesn't really matter when we plant them. So far, except in 2020, where we had a big yield advantage in planting a little earlier in the control. So I wanted to put the data here to be able to compare to the results of the year and the influence of the planting date in bare ground on the soybean yield, to put in perspective with what we were seeing in our no-till system. So here in our no-till planted at boot stage, we see that the stand is really not so great. So it's usually it's lower than in the control, and it's lower than when we plant the rye at anthesis. The yields also, so 2017, the yields were lower. 2018, they were somewhat comparable. 2019, they were lower. 2020, they were comparable. So it hasn't been very consistent, and those yields are getting really low at a point where if you include the cover crop planting, the cover crop seed, you're not going to be profitable anymore. And one more data that I wanted to throw out there is when we no-till drill. So we've done it not very consistently, but one year we no-till drilled at boot stage. And if you compare here, drilling, planting, the yield was the same. So it seems like drilling is an option if you don't have a planter. And drilling at anthesis here, if you compare drilling at anthesis to planting at anthesis, the yields are also very comparable. So is the stand. So it seems like drilling again is an option if you don't have a planter when you want to plant green. Again, this is just 2 data points, so I would prefer to have a little more to give actual recommendation on that system. 2 things that I wanted to note here is, you see here the lower stand in 2019, so the same as every year, it is lower, except in 2020, and we will get back to that later. But that year, we decided to do a stand count before rolling, so between planting and rolling, and after rolling. And so before rolling, we had actually amazing establishment. We had really good emergence, but then we roll and then we lose a lot of soybeans. So this is something that we had not quantified before, but we kind of thought about it as we could see that the stand counts were much lower in the planting at boot stage compared to planting at anthesis. So we were definitely going to kill soybeans if we roll on top of them. And I think it's okay to some extent, because as Heidi mentioned, the soybeans will compensate. So a lower stand to some extent means lower yield, but there is a little wiggle room in here. And again, soybeans do compensate. Another thing that I want to show here is we see the high stand here in the no-till plant at boot stage. it is actually higher than in the no-till at anthesis and even higher than in the control, which is very unusual compared to the previous years. And what we did that year, because we were going for another system, and I'm not going to go into details into this, is that we had a skip row in the rye stand. So here you can see that we skipped 1 row every 3 rows, and that's where the soybeans were planted. So we got a little better establishment by doing that. And again, that was random. We didn't really, that was not the intention here to do the exact same system as the previous years, but we ended up learning something here doing this. So here I wanted to look again at the yields, and I color coded them because I will show the weather, because I think the climate has a big impact on whether or not the system is going to work. So here you see the biggest yield difference with 13 bushel difference. Here, the second lowest, 9 bushel difference between planting at boot stage and planting at anthesis. Here, 5 bushel difference, 4 bushel difference. So the biggest difference here is in red, then it's orange, light green, and darker green. And if you follow the years here, so here the biggest yield difference, here the lowest yield difference, and those should have been, well, no, because they're going with the years. And so what we can observe here is a graph with the soil temperature at 2 inches deep. And so we can see, first of all, that 2018, where the difference was not too big, was a really abnormal year. It got really warm very quickly, and the soil temperature were actually already above 70 degrees when we planted the early planted soybeans. So obviously that helped them a lot, and they got out of the ground really quickly, and that's probably why we're not seeing that big. That's pretty big part of the explanation why we don't see that big of a difference between planting early and planting late that year. And then the darker green here, we see that the temperature were as low as the other years to start with, but it still was the best, the year that saw the lowest difference between the 2 planting dates. Well, I don't know how to explain that exactly. It seems like the temperatures are a little higher, not that much higher, definitely higher than 2019. So the temperatures don't explain everything, but they can definitely help. We know that soybeans will take up to a week to emerge if they're planted at 50 Fahrenheit, and they will pop right out of the ground if they are planted at 77. So the warmer the soil when you plant it, the better that system of planting grain versus planting at anthesis will work. The other thing that we have to pay attention to is moisture. So moisture is important. 2020, we had a big rainfall a few days after planting. And then after that, we had a little rain here and there. 2020 was just a perfect year for us. We had the perfect temperature, the perfect amount of moisture, and that's probably why the yields are not so different. And 2019, another reason why 2019 was probably a big difference between those 2 systems is that it just rained and rained and rained. So we had rain almost every day between the time when we planted May 15 all the way until the end of May. So the beans were just kind of sitting in the cold and wet soil, and the conditions were probably not the best at planting. So we probably had trouble with the furrow closure. So the seeds were probably exposed to all sorts of pests and diseases. So here is just, I've just been working on that for the past week. I don't have all the answers, but I thought it was interesting. And I keep wanting to recommend that if you want to do that, just make sure that the weather looks like it's going to warm up for the next couple of weeks, and it looks like it's not going to rain every day. Otherwise, I would highly recommend planting it, waiting a couple of weeks and planting it anthesis. Another thing that we've observed was comparing boot stage and anthesis planting, and it's a big problem if you have wheat in your rotation, is the volunteer rye the subsequent year. So a lot of farmers have just put the wheat really far away from the soybean and rye system because there will be rye regrowth no matter when you terminate your cover crop and when you plant your soybeans. But what we've observed, and here, those are 2 different cover crop rye varieties. So this is Aeroseeder and this is Spooner. And what we've observed is that when we plant at boot stage, this is the number of rye heads per acre. The year after that we saw growing in our small grain crop, we had a spring planted oats or spring planted barley in that field the following year. And we saw that when we planted the soybeans earlier, we had more rye regrowth than when we planted the soybeans later. So one thing that I'm thinking about here is that the planter does disturb the rye quite a lot, and the rye is earlier in its growing stage that is probably shooting out more tillers. This is my theory, and it hasn't been proven, and I don't know exactly why we're observing that, but something really to keep in mind when you're going to do that, if you have wheat in your rotation especially. And we can see here is the average for a spooner, and here is the average for a roostug. But this is just 1 year, and we see that there is a difference between rye regrowth depending on the rye variety. One last thing that I wanted to mention about that system, because some farmers have tried it this past year and were a little worried about that, is that you will have leggy soybeans. They're going to look funny because you will see that they will try to reach for the light. And you see here the distance between the soil and the first cotyledon, it's pretty long. And here is later in the season, and they're still very long, and they become very crooked and look very funny, but I don't think that has any sort of impact on yield or standability because they don't really lodge more than the others. It's just that they're going to look a little funny for a while, and it has been worrying some farmers. So I collected the data this past year and measured the distance between the ground and the first unifoliate leaves. So when we planted at boot, so planting earlier, it was 5.9 inches, so pretty long between the soil and the first leaves here. When we planted at anthesis, it was a little more than an inch shorter, and if we planted into bare ground, it was, again, here much shorter. So that's all I have for today. Thanks for listening, and I will take any question, and if you have more questions or thoughts after, you're more than welcome to email me.
Awesome. Thank you so much, Leah. I am going to invite the rest of the panelists to join the panel discussion. So Heidi, if you want to unmute yourself, just double check that I have you unmuted.
Test.
Oh, perfect. Awesome. That looks great. And I'm going to pin you. And then I also invited that if Sam wants to join in and answering any questions, same goes for Lamont with any of his experiences, don't hesitate to unmute yourself and join the conversation. We did get quite a few questions, and so I am just going to get started with some of the ones that our attendees had asked. So one of the questions I think was specifically to you, Heidi, about your findings of slug damage and if it's related to the cover crop species that's planted.
Yeah, so the 1 year where we had a significant yield reduction that we attributed to slug damage, and there was also a little bit of drought on top of that. That was a farmer cooperator site where they had a three-way mixture of hairy vetch, triticale, and Austrian winter pea. And I don't necessarily want to attribute the higher slug damage to that particular mix because I think one site year is not enough evidence. I think it was a combination of things. I do think we measured our damage in corn at V5, so well into the growing season when the cover crop that had been early killed was really decomposed quite a lot, and it was because that high nitrogen hairy vetch and the pea had the residue is pretty much gone. Where we planted green into that, there was still quite a bit of residue. And I guess I think that the planted green plots might have acted as like a refuge for the slugs that were trying to escape the heat where there was no cover in the early kill, but that's a little bit of conjecture and maybe an anomaly. But yeah, for the most part, there was no significant difference in damage, and it's just, I guess, a caution because there is a lot of anecdotal evidence about slugs slug damage significantly being reduced by planting green. And I just want to put our results out there to kind of be in contrast to that.
Thanks, Heidi. Leah, did you have any experience with slug damage in any of your rye plots as well for when you planted green?
We don't have slugs in Wisconsin.
All right. Well, maybe we'll have to replicate that in Pennsylvania to try to figure it out. All right. So the next question came from another attendee. So did you try planting green without crimping first with either a drill or a planter, and did you always use row cleaners? I think that was in regards to Heidi's presentation as well.
Yeah, so for our research station sites, we always did the rolling and planting at the same time in one pass because we had that equipment. Some of the sites did not roll. I do believe all of the sites that were included did have row cleaners, but there are plenty of farmers out there that don't like that much disturbance. I'd call them like the varsity cover croppers who have been doing this for many years and have found that the row cleaners, they just don't like how much bare soil is there when they do use the row cleaners or the trash whippers. So they've taken those off and just, depended on the no-till coulter to do a good enough job of opening up that furrow, and they've been happy. And in regards to the order of planting and rolling, I do think that Leah's research really did a good job of addressing that. We did not evaluate that specifically. For the sites that did roll, they were all if it wasn't in the one pass, it was rolled first and then planted. We didn't do any vice versa, so I don't have experience with that.
Thanks. The next question comes from Alyssa. She asked about starting no-till methods when you have rows full of weeds, or maybe you have some weedy patches. How would you suggest, what's the best method for reducing that weed pressure when you're attempting to start a no-till grain rotation? Leah or Heidi, feel free to offer any thoughts on this topic.
Yeah, one thing I wanted to say is that this is no-till in the phase where we plant the soybeans into the small grain, but before planting the small grain, we do till. We do actually a bunch of tillage to prepare the seed bed to plant the small grain into it. There is a little bit of research that is being done with no-tilling small grains into several different cover crops, but this is very in the preliminary stages, and I would not recommend anyone to do any of that yet, at least on big acres. If you have a high weed pressure, so the no-till soybean system will work better against small seeded weeds than large seeded weeds. It will work better against annual weeds, and it definitely doesn't work if you have perennial weeds. So if you have any issue with thistle or quaggrass, this is really not the system for you. Yeah, I think those are my thoughts, but I mean, if you have weeds to start with, I would just till before I plant anything into them.
Thanks, Leah. Yeah, those are great suggestions. One person was asking about just clarifying between a no-till planter and a no-till drill. Could either of you maybe touch on, you both have mentioned both those pieces of equipment in your research, and just what the differences are and maybe which systems they would each work best in?
I saw that I put a slide together quickly, just for a visual. Do you see the screen? So this is a no-till drill, and this is a no-till planter. So for people in Europe, the drill is really what you are going to use to plant your small grain that's on narrow rows. So I think it's 15 centimeters. And the planter is really what you use for row crops like corn and soybeans. and I don't know about the technicalities of how do you mechanically describe the difference between a planter and a drill. Maybe Sam can help us with that.
Yeah, drills are typically used for smaller seeded crops, like your small grains, and planters. Yeah, are usually. Did you already cover that? Yeah, they're usually used for soybeans and corn for planters. So it just sort of, it's the setup really. It's not really so like a grain drill will have like a central fill hopper, whereas planters will have separate hoppers per row. And generally you aren't planting a small grain with a planter. That's kind of what makes it different. It's just the style of the feed to the slot and the singulator. So I don't know if that helps, but it's just a different method of planting between the two.
Thanks, Sam. While you're there, I'm going to ask you another question. So we got some questions about smaller scale applications of no-till and in like vegetable production. So I was wondering if you could touch on that, maybe some pieces of equipment that work well in that system, and even on the topic of planting green, how maybe we utilize at Rodale living covers in some of our systems as well.
Sure, depending on how small scale we're talking. If we're talking like 10 or 20 acres in vegetable production, they do make smaller rollers that can go on the back of a 50 or 60 horsepower tractor. If we're talking even smaller than that, I&J Manufacturing does make a roller that can be pulled by an ATV, or even sometimes they're as small as like you could even use like a lawnmower to pull something like that. So they do make these things, and they are becoming more common. In vegetable production, I've seen it used most successfully with vining crops, things like pumpkins. I haven't seen anyone do watermelons, but I imagine it would work fairly well because you have that mat, and then they're able to just sort of creep out over the top and cover a canopy so weeds don't come up. But for that, you'll also need a way, if you're a scale that's, at that 10 to 20 acre scale, you're going to need a way to get your transplants into the ground once you've rolled down that cover with your smaller roller. And in that case, a no-till water wheel transplanter, they do make those. And the only difference between that and a normal water wheel is that they have a disc that can cut through the residue. It's usually the case with a lot of no-till equipment. It needs to be heavier, and they need a disc to be able to cut through and plant. If you're doing something like this by hand, you're talking about 1 or 2 acres, you have your little mower drawn roller, you can plant by hand directly into the residue, maybe using a couple stakes to make space for your transplants. So yeah, I&J does make some. BCS, they make the walk behind tractors. They have a roller for the front as well. And if you're talking really small scale, super low cost, you can make these things. It looks sort of just like an old fashioned push mower with a drum. You fill with water. It's got the crimping fins on it. You can push that over, a very small area and roll down some cover. At this point, I would pretty much only recommend cereal rye to roll down. And again, like Heidi was talking about, this is going to affect soil temperature too. So if you imagine planting tomatoes in something like a rolled down rye, it could keep the soil a little too cool for that, actually. It may not be, end up how you want. It could stunt them a little bit. So it's happening. It's just not as common in vegetable production. So I'd encourage everybody to experiment with it if they could.
Thanks, Sam. That's great information. And going off of your comment about just suggesting rye really as the only cover, another great question is, we've seen how successful the organic no-till soybean into a rye cover has been. Is there any research either from Rodale or Penn State or University of Wisconsin that's looking at other cover crop species and mixtures that may allow for like an earlier planting, or even that would help make the corn into a rolled down cover or into a living cover work better?
I can actually share a fact sheet into the chat with everybody. Penn State had a reduced tillage organic systems experiment for several years, where they were doing some work with that soybeans into rolled rye. And they were also, I believe, looking at corn into hairy vetch or mixtures of hairy vetch and cereal rye or triticale. And I am not very well versed in that experiment. However, this fact sheet does talk about what they learned and shows, you know, that what they found with being successful rolling hairy vetch is that it's best to wait until it looks like mid pod to early pod set to roll for a good kill. So yeah, I don't want to incriminate myself by saying something incorrect, so I will just direct you to that fact sheet. And John Wallace is on. He could probably fill everybody in on that that project. He was involved heavily with that.
As far as planting earlier, I don't know if there is any research being done, but the thing is that winter barley could be an option. So winter barley flowers a little earlier than winter rye. The thing is that in Wisconsin, it does not overwinter consistently. So if you're somewhere that is a little further south and you can overwinter winter barley, that could be something to look into. I don't know of any research that's been done for cover crops that can be terminated earlier for soybeans. I know that Joel Grover at Western Illinois University is looking into adding some diversity to it. So not growing only rye, but not to terminate earlier, just to add diversity into the system. So having rye with crimson clover, rye with buckwheat, rye was, I don't know exactly what he has, and I'm sure he would be able, he's easy to find, and he would be more than happy to answer any question about that. As far as rolling cover crops for no-till corn in Wisconsin, again, we have not had much luck with that. So we've tried a bunch of different things, including crimson clover. I was not very impressed with it because it does not put on a lot of biomass in the spring. Again, in Wisconsin, because our winters are hard and long, it would be maybe a little better in southern, further south. With the hairy vetch system, it's as Heidi mentioned, you want to wait until the early pod stage, which happens mid-June in Wisconsin. So mid-June, you probably don't want to wait until that long to plant your corn. So those are all the things that we've been working on. We've also been working on living mulches for corn. So planting into a living mulch of medium red clover that will be subsequently managed with a mower or a roller crimper or a flamer between the rows of corn. So this is high maintenance because the clover will grow back strong. And so you will have to manage that cover crop between the rows, and we haven't really figured out the system. We haven't had any decent yield with that system yet, but those are all the things that UW-Madison in partnership with the Rodale Institute have been working on.
Awesome, thank you, Leah. So a couple other questions coming in. So how long do you generally wait to plant after you, Alyssa said mow down a cover crop. I guess this could potentially mean like either rolling a cover crop with a roller crimper and organic system, or even rolling in a conventional system as well. Is there a general rule of thumb that people use for planting into that cover?
Go ahead, Sam.
No, you go ahead. I'm good. I'll take it if no one else takes it.
No, my perspective is from conventional systems. I mean, the old wisdom is burn down 2 weeks before, terminate 2 weeks before you want to plant. But that window is shifting smaller and smaller as more people move to planting green, and as genetics improve and seedling vigor improves of the different varieties, and they can handle more stress, as young plants. But yeah, as for organic, Sam or Leah.
Regarding how long after you mow a cover crop down. So you're talking about incorporating the cover crop in the ground, is my understanding here. And I think two things that I would think about is how is the seeder-in ratio is one of them. So as you wait longer for the cover crop to develop in the spring, the seeder-in ratio tends to increase, and that's true even for legumes. And I've seen a crop of corn following a cover of clover that was set back because the clover tied up the nitrogen, which you don't expect that from a legume, but because the clover was at such an advanced stage and we terminated it way too close to planting. So I'm talking here maybe 2-3 weeks before planting. So it seems like you want to be probably around a month before planting, and I'm just throwing a random amount of time here, but I would be comfortable doing that, and I would not be comfortable pushing it much closer than like 3 weeks before planting, because you need to be able to incorporate in the ground to have a good seed bed to plant your crop into it, and also because you don't want to have that issue with the nitrogen tie-up of the previous crop, even if it's a legume.
I guess something I just thought of that wasn't clear to me from the question is if it is tilled in, or if they're thinking no-till. So in a no-till situation, you would not want to mow the cover crop. You need that stem to be attached to the root so that it can be, pushed in the direction you want, because if you mow and it's like a loose mat residue, then you have no control, and you'll have a poor establishment, I would think.
Thank you, guys. Yeah, and I just want to throw in a comment that Dean James has made. He spoke on our first panel, so he has a lot of great information to share. So thanks for this note, but it said our preference is to roll first, then crimp. That allows the planter to place the seed without interference from the cover crop. The seed openers do not need to cut the cover crop while making the seed slot. So thanks for that great information. And that actually, I'm going to share another question that came from someone that's looking, it says, we're looking to put in field peas early and let them fix their nitrogen and help suppress the weeds with their dense canopy, then roll and crimp them and put our pumpkins in after. They had significant weed pressure last year and they don't use any chemicals. So what are the potential concerns with the roller crimping field peas?
I could take that maybe. I've spoken with a couple farmers that have tried this, and in their experience, field peas actually, they've had some difficulty killing field peas with a roller crimper, if you can believe it. They have that thin, hollow, sort of fragile stem, but it's actually the woodiness, the more carbonaceous cover crops that kill more effectively when you roll them than something that seems like it would kill easier, like a fragile pea. So actually crimping them, they can curl up and come back pretty easily if you can't get an effective 1 or 2 rolls over them. I think it's a good idea, but my guess is that you'd have to wait much later. You'd have to wait until peas are well into their reproductive phase before you can effectively kill them with a roller. That's just my guess. I haven't tried it myself, but from the growers I've spoken with, I've seen some really, really nice fields of Austrian winter pea cover crop that just didn't roll down so great. So it's worth a shot. I wouldn't put all my chips in that basket.
I can add a little bit to that. So I've tried rolling peas, and so in Wisconsin, again, Austrian winter peas or any kind of winter peas actually do not overwinter but we've tried with spring peas. So we planted the spring peas and then rolled them to plant corn into it. That was a total disaster on the corn side, but we waited until the early pod stage, which is the main advice for rolling down legumes. You want to wait full bloom to early pod stage to terminate them. And we had actually a good termination. The main issue that I would see with that is that peas have a very low-ish C/N ratio compared to cereal rye, and they will decay really fast and also feed the weeds because they're a legume and they're very rich in nitrogen. So as they will not provide you with weed control through the entire season as a cover crop of rye would. So you could mix it with a grass if you wanted to do that, would be my main advice, but I would be a little cautious with using just legumes for that. And I know Rodale has success with rolling down hairy vetch in corn and having good weed control during the season. But again, I don't have experience with winter peas, which put on more biomass than spring peas because they do not overwinter here in Wisconsin.
Awesome. Thanks, guys. So I want to take the last couple minutes and shift from some questions. We didn't get the chance to talk about drone seeding and interseeding, but I was wondering if Heidi could talk a little bit about her experiences with interseeding and how potentially that can be applicable in organic systems in the future and how it's currently being used by farmers in Pennsylvania. And same kind of goes for drone seeding, some of these innovative equipments that we're seeing farmers use now.
Yeah, so Penn State has done quite a lot of research on interseeding into cover crops into corn around the V5 stage, and results from several years ago, a project they did at multiple sites, showed that it tends to work better at more northern latitudes. The lower yielding areas in the state where the corn doesn't canopy over so quickly, so that the cover crop has time to establish. Whereas in the south and southeast here, where I'm located, super high yielding locations, the corn canopies over, is very aggressive and canopies quickly. And that can make it tough for cover crops to establish when they have to last from the middle of June through, harvest. So the species that have been most successful has definitely been annual ryegrass into corn. And I believe that red clover has been somewhat successful as well. Cereal rye is not typically used. It's favored, but annual ryegrass is favored over cereal rye. And then I have recently started looking into interseeding, but by broadcasting into standing soybeans before leaf drop. So between soybeans at late in the pod stage around R6, but before the leaves turn yellow and fall off, so you don't have all that residue on the ground. And that was prompted by farmer interest. So I believe Jim Hershey is doing that already, and he's doing it successfully. But we don't have a lot of research on that, at least in our area. So taking a look at that, and the difficult thing with interseeding, with broadcasting specifically, is that you are beholden 100% to whether you get rain or not in a timely manner after you broadcast. Of course, the weather really affects the interseeding into corn earlier in the summer too. At our webinar earlier this morning, Dr. Wallace was talking about interseeding, so I'm just going to steal his words. So, they found in a year that there's ample moisture at corn stage V5, cover crops come up beautifully, they're thriving. Then, in Pennsylvania, we often have a midsummer drought. They shriveled up, ran out of water, became a stressor to the corn, and then that's a waste of money for the cover crop seed, and you can potentially have reduced corn yield. So both that drill interseeding into corn and the broadcast interseeding into soybeans is challenging, but there's potential there. Like, someone said at the earlier webinar, if you're committed to doing it and you are willing to change your management and maybe deal with some setbacks, but keep trying new things, you'll find a way to do it. But and I know we have Dr. Wallace is working on a continued research project. It'll be in New York State, several locations in Pennsylvania, and maybe a couple spots in Maryland as well. So continuing to look at the drill interseeding and optimizing that practice. So that data is forthcoming, but hopefully we have more information coming out in the next couple of years.
Awesome. Thank you so much. And I just want to take a moment as we as some final notes, just to thank our panelists. It was wonderful to have everybody together to have such unique perspectives on this system and how this system is going to advance in the future. And we look forward to hearing from a lot of our farmers who are going to be testing these out in the near future to hear how successful some of these rotations are going to be. So just a nice reminder that we are going to have another webinar next Wednesday. It's going to be on our organic transition program with the crop consulting team. So you'll hear from the three of us that you've heard from today, as well as another member of our team, Nick Podell. And all attendees that have registered for any webinars this year are welcome to use our course code that gets them 30% off on any virtual courses. So please feel free to write that down. And like I said, this will be emailed to all the participants after it's posted on our website. So thank you again to everybody. Thank you to our panelists, and thanks for such great questions. I hope everybody has a great rest of your afternoon.